Good morning. Now we are going to discuss about glycolysis. Glycolysis is a Greek term. This term belongs to Greek. This is a Greek term. In the term, two small terms are present: glycose and lysis. Glycose means sugar. Lysis means splitting. Splitting of sugar is called glycolysis. Splitting of sugar is called glycolysis. Next one. Glycolysis occurs in cytoplasm. This process occurs in cytoplasm. So, glycolysis is also called cytosolic respiration. Glycolysis occurs in cytoplasm, hence that one is also called glycolysis is also called cytosolic respiration. Clear? Yes. Cytosolic respiration. Glycolysis occurs in both aerobic respiration and anaerobic respiration. Glycolysis occurs in both aerobic respiration and anaerobic respiration. Anaerobic respiration. Glycolysis occurs in both aerobic respiration and anaerobic respiration. So, glycolysis is also called core respiration. This process is also called core respiration. Glycolysis is called cytosolic respiration. This one is also called core respiration. Okay, now as in glycolysis, glucose molecule partially oxidized into two pyruvic acids. Glycolysis, glucose molecule, glucose partially oxidized into two pyruvic acids. One glucose molecule break down into two pyruvic acids. Two pyruvic acids. But in glycolysis process, oxygen is not utilized. Oxygen is not utilized. CO2 is not released during glycolysis. CO2 is not released. Oxygen is not utilized and CO2 is not released during glycolysis process. Next form. Okay, during glycolysis, okay, one oxidation occurs. Partial oxidation, one oxidation occurs. Due to oxidation, two NADH plus H plus are formed. H plus H plus formed. Okay, next one. During glycolysis, two ATPs are utilized. Two ATPs utilized. Clear? Next one. Four ATPs are formed. Four ATPs formed. Two NADH formed. Two ATPs are replaced and four ATPs are formed. Okay, net released ATPs is equal to net released ATPs is equal to 2. Net released NADH plus H plus is equal to 2. Okay, now glycolysis is not completed in single step. Glycolysis is not completed in single step. For completion of glycolysis, total 10 biochemical reactions are required. 10 biochemical reactions are required for completion of glycolysis. So glycolysis is a pathway. Glycolysis is a pathway. Glycolysis is a linear pathway. It is a linear pathway. Okay, so this is about brief introduction, not completed. Okay, yes, we completed few things about glycolysis. Glycolysis occurs in cytoplasm, hence that is also called cytosolic respiration. Glycolysis occurs in both aerobic respiration and anaerobic respiration, so that one is called co-respiration. Okay, yes. During glycolysis, glucose molecule is partially oxidized into two pyruvic acids. During the process, oxygen is not utilized, CO2 is not released. Okay, two NADH plus H plus are formed. Okay, two ATPs are utilized. Sorry, four ATPs are formed. Net released ATPs is equal to 2 during glycolysis. Net released NADH plus H plus is equal to 2. For completion of glycolysis, total 10 biochemical reactions are required. So glycolysis is a pathway. Okay, it is a linear pathway. Clear? Yes. Now we are going to discuss a few more things. This pathway was discovered by three scientists. Who are they? Emden, Meyerhoff, and Parnas. If we take first letters from those three names, okay, we got E for Emden, M for Meyer, P for Parnas. So glycolysis pathway is also called EMP pathway. EMP pathway. Emden, Meyerhoff, Parnas pathway. Okay? Yes. Now we are going to discuss about glycolysis in detailed manner. Okay? Yes. First of all, okay, polysaccharides are hydrolyzed into simple sugars. Polysaccharides. Hydrolyzed into simple sugars. Those simple sugars are involved in glycolysis process. Clear? Yes. For example, we take sucrose. Sucrose is not a polysaccharide. That one is a disaccharide. That sucrose disaccharide hydrolyzed into glucose and fructose. Glucose and fructose. Okay, sucrose is a disaccharide. That one hydrolyzed into glucose and fructose. Okay, in the presence of invertase enzyme. Invertase. Okay, in the presence of invertase enzyme, sucrose molecule hydrolyzed into glucose and fructose. This one is disaccharide. Glucose and fructose are monosaccharides. These glucoses and fructoses are involved in glycolysis process. Clear? Okay. Now we are going to discuss about glycolysis in detailed manner. First of all, glucose molecule. First step in glycolysis, glucose is converted into glucose 6-phosphate. Glucose 6-phosphate. Glucose molecule is converted into glucose 6-phosphate by utilizing ATP in the presence of hexokinase enzyme. Hexokinase. In the presence of hexokinase, glucose is converted into glucose 6-phosphate by utilizing ATP. That is the first biochemical reaction in glycolysis. Second biochemical reaction is that glucose 6-phosphate is converted into glucose 6-phosphate. Phosphate is converted into its isomer. What's the isomer of glucose 6-phosphate? Fructose 6-phosphate. Glucose 6-phosphate is converted into its isomer, that is fructose 6-phosphate. Clear? In the presence of phosphoisomerase, in the presence of isomerase enzyme. In the presence of isomerase enzyme, glucose 6-phosphate is converted into its isomer, that is fructose 6-phosphate. Clear? Next step. In third step, fructose 6-phosphate is converted into fructose 6-phosphate. Fructose 6-phosphate is converted into fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate. Clear? Yes, in the presence of phosphofructokinase enzyme. Phosphofructokinase. Phosphofructokinase. Here one ATP is utilized. Here also one more ATP is utilized. Total 2 ATPs utilized in glycolysis process. Clear? Yes. Phosphofructokinase enzyme is a pacemaker enzyme. Generally, enzymes are involved in bidirectional reactions, but this enzyme is involved only forward reaction. that enzyme never catalyzed backward reaction. So the type of enzyme is called pacemaker enzyme. That enzyme is called phosphofructokinase enzyme is called pacemaker enzyme. Next one. Fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate. This is a short form. Fructose 1,6-bisphosphate is breakdown into 1 G3P molecule. G3P means glyceraldehyde. Three phosphate. Glyceraldehyde 3-phosphate plus DOP. DOP means dihydroxyacetone phosphate. Dihydroxy acetone phosphate. These two are triages. These two are also isomers. Glyceraldehyde 3-phosphate and dihydroxyacetone phosphate are also isomers. This reaction is catalyzed by an enzyme. Enzyme name is aldolase. In the presence of aldolase enzyme, fructose 1,6-bisphosphate break down into glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. So this is a cleavage reaction. This is a splitting reaction. Cleavage or splitting reaction. And next step, dihydroxyacetone phosphate, dihydroxyacetone phosphate, dihydroxyacetone phosphate, DHAP, dihydroxyacetone phosphate, dihydroxyacetone phosphate is converted into its isomer. What is its isomer? Glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. In the presence of triose phosphoisomerase, triose phosphoisomerase enzyme. Clear? So we completed just 5 biochemical reactions in glycolysis. 1, 2, 3, 4 and 5. Remaining 5 biochemical reactions we will discuss it in next class. Okay, thank you very much.